Okay, welcome back to Tech Talks Education. We are continuing with having a look at the calculation of empirical and molecular formula of compounds. We are going to look at something which is a bit new but closely related to what we have been doing. So let us try to see. In this case, you may not be given what we call percentage composition, but you may be given masses of the elements. So you should know how to deal with the masses of the elements when given and when it is not the percentage composition given. So let us look at this number as well. When dry carbon monoxide was passed over 12 grams of a heated oxide of iron, 8.4 grams of oxygen, 8.4 grams of iron remained. So in the first part we are supposed to calculate the simplest formula of the compound. In part B, Roman 1, write equation for the reaction that took place. And then Roman 2, state the industrial application of the above reaction. So here we are given that the relative atomic mass of iron is 56 and that of oxygen is 16. So we are good to go. Now we are going to seriously think. We have been given that dry carbon monoxide gas was passed over 12 grams of a heated oxide of iron. This is the combined mass of the oxygen in this compound and then iron, which has combined with the oxygen. The total mass is 12 grams. Now, when dry carbon dioxide gas was passed over the heated oxide of iron, they said that 8.4 grams of iron remained. What happened in this case? We must understand the role played by carbon monoxide in this reaction here. Carbon monoxide is a reducing agent. So, in this case, as a reducing agent, it removes the oxygen atoms found in the oxide of iron in this reaction here. So, after removing all the oxygen atoms, then we remain with only iron. So, this 8.4 grams is the mass of iron only. So, why is it that there is a variation in mass here? There has been a reduction in mass from 12 grams to 8.4 grams. That one is simply because carbon monoxide removed those oxygen atoms and the mass had to reduce from 12 grams to 8.4 grams. So they say that that is the mass of iron that remained. So we don't know the mass of oxygen. We have only the mass of iron. So let us work out the mass of oxygen. So the mass of oxygen is equal to the 12 grams minus the 8.4 grams that remained. And what we have in this case is 12 minus 8.4, which is 3.6 grams. This is the mass of oxygen only in this heated oxide of iron. So the 8.4 grams is the mass of iron. Now let us calculate the simplest formula using the method that we have seen earlier on. So we shall start with the elements found in this compound. The elements are iron and we have oxygen. Then we go to, instead of percentage composition now, we are going to deal with the mass of each element directly. So we go to mass, that is the mass composition of iron is 8.4, that one of oxygen is 3.6. Then we have to know or remind ourselves about the relative atomic mass of each element. So for iron is 56, oxygen is 16. So we go now to the moles of each element. So in getting the mole, we know that it is going to be the mass also, we divide by the relative atomic mass. That is for each element, 3.6 over 16. So what we get from the calculator is equal to, let us get it very fast, 8.4, we divide by 56. So this one has given me 0.15. Then 3.6 divided by 16. This one has given me 0.225. So this is our mole ratio in this case. I mean the number of moles of each element that we have got. So for oxygen is 3.6 divided by 16 and it is 0.225, and for iron is 8.4 divided by 56 and is 0.15. So these are the number of moles. Don't round off. Let's come to the mole ratio. So the mole ratio, we are going to divide by the smaller number of moles. Mark Q. This one looks to be longer, but we need to mind about the place values. This is ones. Then we have tenth. In tenth, this one is 1 and this one is 2. So this one is bigger than this. And for that reason, we shall divide by the smaller number of moles. In this case, the mole ratio is 0.15. We divide this one by 0.15. This one also, it is 0.225. We divide by, these are yet the number of moles. Let's go to the mole ratio. So it is 0.15. We divide by itself, and then 0.225. We also divide by 0.15. Let us try to see what we get. In this case, what we get from here will be 1, a ratio of 1 to, so 0.225, we divide by this, and here we have exactly 1.5. Now try to see, we have a ratio of 1 to 1.5. So what do? We make sure that it is to 1 decimal place, if it is not to 1 decimal place. So in this case, 1.5 is to 1 decimal place. We are only going to convert it now to a fraction. Using our method as we saw, we shall make this one here, we shall do it as a side work. So it is 1.5. Therefore, we start somewhere from 0.5, then we go to 1.5. What do? We get the fraction that corresponds to exactly 0.5, which is a half. The one that corresponds to 1.5 is got by adding the denominator to the numerator, which is 3 over 2. Then we bring the fraction which corresponds to our 1.5. It will be 1 to 3 over 2 and multiply both sides by the denominator. So our ratio is 2 to 3. And then it means that our empirical formula is or our simplest formula is Fe2 or 3. So we have got the simplest formula in this case. Now let us go to the next part, which is saying we should write the equation for the reaction that took place. The equation for the reaction that took place, we need to analyze this reaction here very well. The equation for the reaction that took place. What is reacting with what? I can see that here we passed dry carbon monoxide over a heated oxide of iron. The formula of the oxide of the iron we have got it is here, Fe2O3. We are passing dry carbon monoxide over it. So this one is now B part 1. So we are having Fe2O3. This compound is what we call iron 3 oxide. We are reacting heated iron 3 oxide with dry carbon monoxide gas. So what do we get in this case? The carbon monoxide will remove the oxygen atoms as a reducing agent, and we get iron remaining. As well, the carbon monoxide will be oxidized to carbon dioxide gas. Now let us try to balance this equation here. We have 3 oxygen atoms and 1 here. This is 2. So let us try to make the number of oxygen atoms go to 6 by multiplying carbon monoxide by 3. So 6 oxygen atoms, meaning that we multiply carbon dioxide by 3. 3 carbon atoms on the product side, on the reactant side also the same. Then on the reactant side, we have 2 ion atoms, and here on the product side, we have 1 ion atom multiplied by 2. So we have already got the equation for the reaction between the heated oxide of iron and then carbon monoxide. And finally, we go to Roman 2. They are saying, what is the industrial application of this reaction here? So if you see this iron 3 oxide, it is one of the ores of iron, or one of the compounds from which iron can be extracted or obtained. And iron, being a metal which is moderately reactive, it forms a compound which is not so stable, which is not also so unstable. And in this case, we can extract iron from its ore by the method of reduction using carbon monoxide. And this one is an industrial process which takes place at a large scale in industries. So this process here is applied, or this reaction is applied in the extraction of iron. So this one here, we shall look at it later. The extraction of iron which takes place in the blast furnace by the reduction of the ore of iron, in this case using carbon monoxide. So that is our part of the continuation of the calculation of empirical and molecular formula. Next is we are going to deal with a hydrated compound. So thank you for watching.